All right, calculus, we're going to be looking at economic optimization. So what's the difference between economics and just optimization in general? Hopefully you can guess this much, but the big idea is money. Money, money, money. All right, let's get started. So this first question that we are looking at here has a situation. It says a trucking company has determined that the cost per hour to operate a single truck is given by this function here. And S is the speed the truck travels. So they're asking us at what speed, that's S, is the total cost per hour a minimum? And what is that cost? So they want to know when, for what S is C is at. So if C of S is a min, then S equals what? And that's the first question. And then whatever that answer is, we want to plug it back into our function C. And what does that equal? So those are our two questions. Let's do the first one. So the first thing that I'm looking at is I see C of S here, and we need to take the derivative. So I look at it, and we have C prime of S. That means we're going to drop this 2. We have 0.0001. And then we got S to the first power. Minus 0.01, the S disappears. Then that constant 112 goes away. So, this isn't really that hard to do by hand. We could, even though the decimals are there, it's really not as hard as you would think. So C prime of S equals this. We want to set that equal to 0 to find our critical values. So it's going to be 0.0002 S and then minus 0.01. So I'm going to move this 0.01 over to the other side. That would give me positive 0.01 equals 0.0002 S. Now, just for my own sake, to kind of simplify this, I see that I could move this decimal 1, 2, 3, 4 times. So I'm going to multiply by a 1 with 4 zeros on both sides, which would be 1, 2, 3, 4. That's 10,000. So I'm going to do that to both sides. 1, 2, 3, 4. So I'm going to move this 4 times, and that becomes 2s on this side. And on the other side, that would give me 1, 2, 3, 4. So it's going to be 100 equals 2s. Divide by 2. S equals 50. So at what speed? It's 50 miles per hour. Are we talking about miles per hour? No, it actually doesn't say it, but it's just the speed. Let's go ahead and say 50 units per hour, whatever that means. 50 kilometers, 50 miles. So now I got to plug in that 50 into the first function. So it'll be C of 50, which would equal 0.0001 times 50 squared minus 0.01 times 50 plus 112. Now, because I've already gotten it to a point where I just plug it in, I'm actually going to leave it there. You guys can calculate that, simplify that if you need. But that's how we work with this problem. This was very straightforward. They gave us a function, told us to find where it is a minimum, and what is that value. That's what we did. All right, this next one. A nursery wants to add a 1,000 square foot rectangular area to its greenhouse to sell seedlings. For aesthetic reasons, they have decided to border the area on 3 sides with cedar siding at a cost of $10 a foot. So we're really just saying that here's our area in the middle. And on 3 of these sides we have the cedar. Let's color that in, how about brown? For like wood. So brown, is this that's like kind of a reddish brown. So we got this side is wood, this side is wood, and this side is wood. And then up top we have the $25 per foot for the mosaic, which is a little bit crazier. We'll color that piece in purple. So when we do the cost, let's call this cost of the mosaic, and the other one we'll call the cost of the cedar or the wood. How about, yeah, we'll call it the cedar. So the cost of the cedar equals $10 per foot. And the cost of the mosaic equals $25 per foot. Now when we add that together, the total cost, so total cost total, is going to be cost of the cedar plus the cost of the mosaic. And that's what we want to maximize. Now let's go ahead and plug in some numbers here, see if we can come up with some values for x. So let's say our width right here is, I don't know, 10. Can we do 10? Sure, we could do 10. So if this is 10, whoops, not 10, not 100, but 10, then that means the area equals the length times the width, which is really 1,000 because it's 1,000 square feet. So 10 times what equals 1,000? That would be 100. Okay, the cedar cost, which would be $10 per square foot, that's going to be $100. The mosaic cost, which is 25, so we got to multiply 25 times 100, which would be 2,500. Total cost then is 2,600. Let's flip-flop those. Let's say our width was, oh, wait a second. Wait a second. We are doing this totally backwards here for a second. The cedar cost is going to be two of these lengths and one of the widths. So that's 10 times 2L plus W. And the mosaic cost is just 25 times one of the W's. So the cedar cost is going to be twice the length plus one of the widths. So that's 200 plus how much? One of the widths is 10, so it's 210 times the cedar cost, which is 10. So that's 210 times 10, or 2,100. Okay, the mosaic cost is 25 times that width, so that's 25 times 10, which is 250. So if we were to add all that together, we would get 250 plus 2,100, or 2,350. Let's try another one. Let's flip-flop these. Let's say the width was 100 and the length was 10. So this is going to be 2 times the length, which is 20, plus the other one, which is 100, times 10. So that's 120 times 10, or 1,200. The other one is 100 times 25, or 2,500. Now if I put those two together, we got 37, is it 3,750 or just 3,700? 3,700. So it really costs, when the width goes up, the total cost goes up. That's what we're kind of looking at. So let's talk about this in terms of x. If the width is x, then I know the length is 1,000 divided by that number. And in terms of x, you know, if we're calling x equals w and L equals 1,000 divided by w, or x, pardon me, then up here, rewriting this, this is going to be 10 times, or this is 20L plus 10W. That would be 20 times L, which is 1,000 over x, plus, what's the other one? W is just x, so 10x. And for this last one, this is going to be 25x. And if we're to simplify that top piece, that'd really be 20,000 over x plus 10x. So that's our cedar cost. That's 20,000 divided by x plus 10 times x. And then the second one is 25x. And the total cost is these two added together. So it's the cedar cost plus the the cost of the cedar plus the cost of the mosaic. We already kind of calculated those. Let's go ahead and put this all together then. The total cost, if we're to put this in terms of x, is going to be 20,000 divided by x plus 10x plus 25x. This 10x and 25x we can combine and make 35x. Now I got a function. I can optimize that one. Let's go ahead and use our graphing calculator to see what it would look. So, calculator. So we're going to go to our y equals here. We can actually enter them as separate, so it's going to be 20,000 divided by x, and we don't need the rest of this piece here, so I'm going to delete those. And then the second one, 20,000 divided by x plus 10x. Plus, then that other piece is going to be 25x. Now I could have combined those, but I just want to show you it doesn't really matter. We can just leave it as is, because we have a calculator working it for us. Clear that one and clear that one. So we're going to graph this. I don't know what my window is right now, but let's take a look at it. I don't even see it in the window. Looks like the most x could be is probably around 100. So, well, maybe not around 100. Let's say 200. No, it could be 1,000, I guess. 1,000. But our cost is probably going to be significantly more than that. You know, our first costs were already at the 2,000s, 3,000. So let's go up to 4,000. And we're going to go every, I don't know, 500 for our interval. So there's the window if you need to look at it. Oh, yeah, we hit a minimum cost right here pretty early. So we need to zoom in on that. So we're looking between 0 and 1. And it looks like if these were in 500s, we got 500, 1,000, 1,500 to about 3,000, somewhere in there. So let's look at, for our y values, we're going to look between 1,500 and 3,000. We're probably going to skip every 100. And then for the x maximum, we're just looking between 0 and, what was that value that we saw there? It was from like 0 to 10 maybe? 0 to 10. We'll mark that every 1. Ah, so I was off. It's not 0 to 10. How about 0 to 50? We can mark it every 5. There we go. That looks prettier. Okay, so we have a minimum somewhere in here. Looks like at about 5, 10, 15, 20, 25, just before 25 for that width equals 25. Okay, so I'm going to go ahead and drag this picture in. You guys can kind of see what we're talking about. And then we're going to calculate that minimum value. So I go to second, calculate. We need a minimum, so I click on 3. And left bound, so just a little bit to the left of this. And then a little bit to the right of it. And in between. Let's see, so we're looking at 23.9045. So right here, this is at 23.9045. That's my width. But what's my height? Actually, no, that would be my total cost. How do I find my length? Not my width, or my height. What's the total cost? Oh, that's all it's asking us. Well, we can look at our calculator to tell us that. It's right here, 1673.32. So we have to spend 1673.32. This is the cost. The money equals $1,673.32. That's the lowest we can get. And the width is about 23 feet for that. Okay, let's look at another one. A real estate company owns 100 apartments in New York City. At $1,000 per month, each apartment can be rented. However, for each $50 increase, there will be 2 additional vacancies. So we start with 100, but then if we were to charge $1,050, now it becomes 98. Okay, so let's see. 0 increases. We got $1,000. Apartment rented 100. So the revenue is the rent times the apartments rented, because it's how much per apartment times the number of apartments rented. So that's going to be, add a couple of zeros on, and we got 1 with 5 zeros. 100,000. Now if I do one $50 increase, so that'd be 1,050. This is going to go down by 2. So the apartments rented is going to go down to 98. Now if we were to multiply those, let's use a calculator here. So we're going to clear this, clear again. We got 1050 times 98, which is a little bit more, but not a lot more. It's 102,900. So this is kind of interesting. We're looking at our rent and then our apartments rented, and we multiply those, we get our revenue. So our rent times the number of apartments equals total. Okay, so if we were to put in 2 for this one here, we have a $50 increase. So that means we're going to have $1,100. That means we're down to 96 now. Let's go ahead and fill all these in and then see if we can calculate them. This next one would be $1,150, another $50 increase. And that would be, how much are we looking at here? So now we're going down 2 more. We're at 94. And then now we're looking at $1,200. We're down to 92. So if we start at, if we're doing 50 increases, that means 50 times 50. Or now we're at $2,500 more, because 50 times $50 increases, that's $2,500. So we started with the 1,000, but now we're adding $2,500. That's $3,500 per apartment. But the problem is that $50 increases times 2 apartments gone, that's 100 apartments gone. So now we have 0 apartments. So that actually would make a revenue of 0. So how do we calculate if this is, how much is the rent? We start with 1,000, but then we're adding $50 per increase, and X equals number of increases. Okay. And here it's going to be, we start out with 100 apartments, but we're going to subtract 2 for every X. And then when we multiply those two things, that gives us our revenue. So right here. So let's figure out these 3 and see if we can at least get an idea of what's happening to the revenue. So let's calculate. We have 1,100 times 96. We have 1,150 times 94. We also have 1,200 times 92. We're still going up. Yeah, we are going up, not super fast, but we are going up. So we have 105,600. I think that's it. And then we have 108,100. Oops, wrong one. There we go. 108,100. and then 110,400. So this one here, we want to maximize that revenue. Let's see if we can plug in those pieces to an equation. So we're going to do our rent times the number of apartments rented. So it's going to be 1,000. Let's put this in parentheses because we're multiplying. 1,000 plus 50 times x times 100 minus 2 times x. Okay, so we're talking our revenue here is in the hundreds of thousands, if you guys remember. So our output needs to be starting at 100,000 and probably going up from there. Our x values are around 1,000, going up to as much as 4,000. So our x values, we can go up from 0 up to 4,000. And we'll go in terms of, let's say, at least 100. How about 200? Our y values, we start out at 100,000. And we're going up to maybe 120,000. And we're going to go in intervals or increments of 1,000. Let's see what we got. We got nothing. Let's start off with 1,000 for x. Still nothing in there? All right, let's look at a table. So, oh, that's right. X starts out not at 1,000. X is the number of $50 increases. So we're only doing up to 50. That's why we're way off. So we need to go from about 0 to 50, and we can increment this in 2. Because X doesn't represent the rent. It represents the number of $50 increases. Aha, so it looks like we reach a maximum somewhere here around that point, but let's see where that point is. So we need to go even higher. So in our y value, we need to go to maybe 130. There we go. Now we hit a definite maximum here. So let's calculate that maximum. Second, calculate maximum. So I'm going to do a left bound, let's say probably at about, I don't know. Right now where am I at? So it looks like the left bound should be probably around 15. Oh, maybe even less. Did you find it? Oh, it did. Right at 15. So let's try and calculate that again, but let's go a little bit lower just to make sure. So I go to calculate the maximum. Left bound, I'm going to do 12. Right bound, I'm going to do 18. Middle, let's say it's about 15. And it gets 14.99995. So we actually hit it right at 15. And we have a big y value as well. So let's see what we got here. So x equals 15. And the revenue is going to equal 122,500. That's a lot of revenue. So it looks like we're actually going to lose about 30 apartments. So out of 100, if we're renting 70 of our apartments, we're reaching a maximum revenue. Okay, I'm going to go ahead and pause or stop this video here for part 1. I'll make a part 2 as well, but just to kind of give you guys a little intermission break. Go get a drink of water, get some sunshine, come back, and let's hit it again.